In this session, we're going to introduce you an interesting extension of hierarchical clustering method called BIRCH, a microclustering-based approach. The BIRCH is an abbreviation of Balanced Iterative Reducing and Clustering Using Hierarchies. It was developed by a group of researchers in University of Wisconsin in 1996. The general philosophy is it incrementally constructs a CF tree, or called a clustering feature tree, which is a hierarchical data structure for multi-phase clustering. For phase 1, essentially it scans the database to construct an initial in-memory CF tree, which is a multi-level compression of the data that tries to preserve the inherent clustering structure of the data. Then at phase 2, it uses an arbitrary clustering algorithm to cluster the leaf nodes of the CF tree. The key idea is multi-level clustering. At the low level, it does microclustering, therefore reduces the complexity and increases scalability. At the high level, it does macro clustering. It leaves enough flexibility for high-level clustering using different clustering methodologies. The BIRCH method scales linearly. That means it finds a good clustering with a single scan, and then improve the quality with a few additional scans. The clustering feature we first introduced is a CF vector in BIRCH. The BIRCH clustering feature essentially is, suppose you get these 5 points into one cluster. Okay. Then suppose these are the 5 points, their positions. Okay. Then the CF vector contains 3 components. One is the number of data points. The second is a linear sum of the points in the cluster. The third one is square sum of the endpoints. Okay. So you probably can see the first one, 5, means there are 5 points. The second one actually is the linear sum of each dimension. Okay. The third one actually is the squared sum of each dimension. Okay. So the clustering feature essentially is a summary of the statistics of a given subcluster, which you can consider the number is the zeros. The first one is a linear, the second one is the second moments of the subcluster from the statistic point of view. That means it registers the crucial measurements for computing cluster and utilize storage quite efficiently. So we can look at the general concepts of centroid, radius, and diameter. Okay. The centroid essentially is the center of the cluster. Okay. Then suppose we have a vector of n dimensions x sub I. Okay. Then the centroid is essentially computing by the sum of all the points in this cluster divided by the number of points in the cluster. So that will get the centroid of the cluster. Okay. Then the radius actually is the average distance from the member objects to the centroid. That essentially is every one. You get a difference with the centroid. Then we use the sum of their squared distance, divide by number of points in the cluster, take their square root. So essentially it's the square root of the average distance from any point of the cluster to its centroid. What is diameter? Diameter essentially is average pairwise distance within the cluster. That means if xi and xj is within the same cluster, so essentially what we will find is there are total n times n minus 1 pairs, and we sum up all these pairwise distance, then get the square root. That's the diameter. Then we look at CF tree structure in BIRCH. The CF tree structure essentially is very much like a B plus tree. We can do incremental insertion of the new points. That means when the new points come, okay, we can find the closest leaf entry, start from the root. Okay. Then we traverse, we find the closed entry. We can add points to the leaf entry and update the clustering feature, CF. If this entry diameter is greater than the maximum diameter, then we'll split the leaf. And if possibly we even will be able to split parents based on the B plus tree algorithm. A CF tree has two parameters. One called branching factor, that means the maximum number of children. Another is maximum diameter of subcluster stored at the leaf nodes. Then a CF tree essentially is high balance tree that store the clustering features. The non-leaf nodes store the sums of clustering features of their children. So we can see BIRCH is an interesting algorithm because it is an integration of agglomerative clustering with other flexible clustering methods. At the low level, we do microclustering. We explore the CF feature and BIRCH tree structure. It preserves the inherent clustering structure of the data. At the high level, we do macroclustering. It provides sufficient flexibility for integration with other clustering methods. So this method actually impacts many other clustering methods and applications for large data sets. There are some concerns. One is the BIRCH tree is still sensitive to the insertion order of the data points. Another is, since the leaf nodes has a fixed size, the clustering obtained may not be as natural. And also the clusters tend to be spherical, given the radius and diameter measure as the major parameters. Still, it is pretty interesting algorithm and can generate quite effective clusters.